Assalamu alaikum. This is module 2 and we are going to talk about sequential programming today, and in this module we are going to see how the operations and expressions, variables and mathematical equations are done in C++. So our course learning outcome is to classify data types, apply operations, expressions in C++. So you start with operations and expressions, then the mathematical functions for week 2 and mathematical functions for week number 3. Now, given a certain problem, we are given a task of writing a program to help a payroll officer who's the guy who calculates the salaries for people. So they compute the pay for the university workers, and we are going to pay each university worker 5 reals per hour. So we need to calculate how many hours the worker works in a certain week, and then multiply it by 5 and find the salary or the weekly salary for that worker. So we should first consider the behavior of our program. What do we need to consider first? First, we need to ask ourselves, what are our inputs and what are our outputs? Then, how do we relate these inputs to the outputs? What operations do we need? So the behavior of the program will look something like this. We will say, for workers payroll calculation, please enter the worker's first name, initial and last name, like here, Ali J Al-Ma'mari. Then please enter the worker's ID. Then we are going to take the worker's ID number, how many hours he worked. Then we need to display the name of the worker, we need to display his ID, and we need to display the amount of money we are going to pay him. The idea over here is not the calculations, rather than what different types of data we have. So first here, for the name, we have characters and string. For the ID number, we have an integer. For the worked hours, we have a real number, because the difference between integer and real number, an integer is a whole number, there's no fractions. A real number, it contains fraction. So maybe the worker has worked for let's say 8.5 hours or 10.5 hours, so this is possible. Then we need to display the worker's name, because we have saved it already, so we can display it. We need to display the worker's ID, and we need to find the calculation, how much we pay him, and display the value. So we have different types of data in this question, and we are going to concentrate on all of this. Now, as you can see, we display a string saying, please enter the your initials and name. Please enter your labels and your family name. So these are displaying a string. So we read a string, which is the first name and the last name. Then we read a character, which is the middle initials. So if you see on our exam, it was Ali J Al-Ma'mari. So this is a string, this is a string, and this guy over here is a character. Now, a string is a combination of characters. A string is a combination of characters. Then we have an integer number, which is the ID number. The ID number cannot be a real number. There is no student ID having, let's say, 1919999.5. We don't have this ID number. ID numbers are usually integer values. ID numbers are usually integer values. Then we go for a real value, which is the hours worked. How many hours did the worker work? So this is considered a real value because he may worked, let's say, 2 hours and a half, 2 hours and a quarter, depends on how many hours he worked. Then we compute the payment, which is the hours worked multiplied by the hourly rate. Then we need to display the ID number and display the payment at the end. So to do this, our algorithm will have to declare a constant called an hourly rate. This constant is a variable that does not change, and usually whenever you see a variable which has all caps locks or all capital letters, it's called a constant. And this constant over here is equal to 5 Omani Riyals because it's fixed in our program, so we cannot change it. Then we are going to see out a statement asking the user to enter first name, last name, and the initials. We are going to read using CN. By now you know CN from the lab. Last name, first name, and the middle initials. Then we are going to see out a message for the user asking him to display his, or asking him to enter his ID number. We are going to read the ID number. Then we are going to ask the user to enter how many hours he worked. We are going to read these hours. Then we are going to compute the payment using hours worked multiplied by hourly wage. Then we are going to display the final information and the payment. So when it comes to coding, executing, and testing, we need to create a program stub. So we need to have the opening documentation. We need to have the compiler directives, which is hashtag include input output stream using namespace std and integer main. We need to have an empty main function. By now you know all of these. Then we need to convert each one of these steps into a C code. Then we need to observe and check whether our code works or not. So of course we are not going to write the program here. It's just I want to show you that we have different types of data. Now types and declarations. First of all, if you want to declare an integer, you are going to say int, which is integer, int. So if I'm going to declare an integer called a, I'm going to say integer a. I can either leave it empty or give it a value of 0. Now make it as a rule, don't leave your variables empty. Do not leave your variables empty, and we are going to discuss why we cannot leave the variables empty. Then integer can either be short, can either be long, or can be unsigned. And we have a table explaining what's the difference between short, long, and unsigned. Then we have the reals, which is the fraction numbers. We have reals, we can either declare them as a float or a double or a long double. Throughout the semester you are going to find that we are using basically double. Okay, we declare our variables as double when they are reals, integer when they are an integer. Then we have characters, which are letters, digits, symbols, punctuations, and we declare them as char or char. The final type is booleans, and we have logical values. They have either true or false, and they are short by bool or bool. So here how these are the famous 4 types of data. So you need to know exactly the different types. So we have either an integer or a double, or character or a boolean. Okay, so we are going to use one of these variables at any time in our semester. Now this table will show you the different types of variables. So if you have a character is of size 1 byte or 8 bits, and usually it is signed. So it is signed, it will take from -127 to 127. In other words, 2 to the power 8 is equal to 256. 256 divided by 2 is 128. So your range will start from -127, it will reach to 0 up to 127, or either from 0 to 255, your full range. You can also have an unsigned character. Signed and unsigned, the idea is, we are going to explain this later, but if it's a signed value, these are our 8 bits. The most significant bit over here will be called the sign bit. Okay, this sign bit will take 1 bit from the 8 bits, so we end up with 7 bits, and 2 to the power 7 is equal to 128. That's why you get the 128 or 127, because 128 minus 1. Unsigned character, usually they take the value from 0 to 255 immediately, which is the full 8 bits. Signed characters, they take from -125, 127 or to 127. Now the next is we have the integer, which is of 4 bytes. Now when we say 4 bytes for an integer, when we say 4 bytes, 1 byte is 8 bits, so 4 multiplied by 8 is 32. So we have 2 to the power 32 is our number. 2 to the power 32 is this value, or it is around 4 billion. Divide 4 billion by 2, it is 2 billion and 2 billion here. 2 billion negative, 2 billion in positive. Or it's either integer or unsigned integer. Then we have signed integer. These are all normal integers. Then you have short, which is 2 bytes. Here is 4, here it's 2. This one is 1 byte. Then we have unsigned short, signed short. Then we have long, which is similar to the signed integer. Signed long, unsigned long. Then we have float, which is 4 bytes, but it has fraction. Then we have double and long double. Usually we use the double, which is 8 bytes, so it is 2 to the power 64 in range, which is a very huge number. So if you want to read this value over here, this one is plus minus 3.4 to multiplied by 10 to the power 38 or minus 38. So it's a number with 38 zeros beside it. So when it comes to integers, you can see over here that the idea is, if I say integer a, this means the value of a, we will go to the memory. This is our memory, and for an integer we are going to preserve 4 bytes. So we are going to take 4 memory locations in the memory. These are 4 memory locations. These are all used to store a. So usually when we declare our variable, immediately a place in the memory will be preserved for it. So for 16 bits we preserve 2 bytes, which is for short integer, 32 bits, which is 4 bytes for long integer or long, remember that you cannot say integer is equal to 5. Integer is equal to 5 means where am I going to store the 5? We need a place, we need a name for that location. So we need to put a name over here. Then integers can be specified as unsigned. Okay, they either signed or unsigned. Usually we are not going to go through signed or unsigned. Usually we are going to say just a normal integer and use it for saving our programs. There are certain cases, I will show you 1 or 2 cases where we had some problems and we had to go for long integers. Now the literals, how do we explain the integers? If I say integer a is equal to 5, this means 5 is decimal. If I say integer a is equal to 0.5, this is octal. And if I say integer a is equal to x5, this is also hexadecimal. So the sequence of digits without a decimal point is for decimal integers. Octal integers begin with a 0. Hexadecimal begin with an x. This is just to make sure that when you see, let's say x5, this is a hexadecimal number. It's not a mistake in typing. Then we have the float and double and long double. These are all real numbers. Real numbers means that these values, they have fraction in them. So as a float, it has from 3.8 10 to the power minus 38 to 10.8 to 3.4 to multiplied by 10 to the power 38. Double, it goes for 8 bytes, so it's a huge number. And long double, it will go for a very extremely large value. So as you can see here, it holds around 128 or 69 bits. The double itself holds 8 bytes for one variable. So when we are explaining the real values, we need to know how to write them down. So first of all, this is the sign of the number. Okay, this is the sign of the number. This is the decimal point. Okay, this is the decimal point, and the decimal point with the fractions is called the mantissa, and these are called also the significant digits. See, this number has 3 significant digits. Then you have the power, 10 to the power, okay, and the sign for the power, which is here minus 4. So we need to know exactly how our numbers are written. So the double objects, as we spoke earlier, this one has this bit as sign. Then you have 11 bits for the exponential, and you have 52 bits for the mantissa. You have 52 bits for the mantissa. So this is in total 64 bits. This is the IEEE standard for floating points. The IEEE standard for floating points. This is at the end of part 1. We are going to continue in part 2, and hopefully everything is clear for you.